Alright guys, so far, since I have to start this recording over, we're learning about exponential growth and decay. This is a formula. A of t represents final value. Output, dependent variable y. Little a represents initial value, starting value. Open parentheses 1 plus or minus the r. R is going to be the percentage in the problem. Make sure you change it to a decimal. If it is increasing, we're going to add the rate. If it is decreasing, we're going to subtract. And then t stands for time, which is our independent variable, or our x. So we already read the first problem. 83,000 is our initial value. 1 plus, because it's appreciating, 6%, 0.06. And then t is 5 years, so raised to the 5. We plugged it into the calculator, and this is what we got. But then I asked the class to highlight it and hit enter, and then you get this really long number. So our answer is not this, actually it's this. And we want the cents, so we're going to put this whole value all the way to 0.72 cents because we're talking about money. So our answer is the condominium after 5 years is going to be worth $111,072.72. So watch out for that in the test. Okay, it's a little trick that I didn't know in the calculator, so watch out. Next one, number 2. It says the value of a truck bought new for $28,000 decrease at 9.5% each year. How much will the truck be worth in 8 years? So again, they want the final value. Can you give me the initial value there, Sione? 28,000. Open parentheses 1. Is it going to be plus or minus, Kevin? Okay, very good. It is minus because we are decreasing. Can you change that rate, that percentage, to a decimal for me, Greg? What would it be? .095. Raised to the t time is going to be easy. What is it? 8 years. Wow, thank you guys for answering. Thanks. Thank you. And then watch out, they might change it. If they give you answer choices in the equation, they might go to the next step, and 1 minus 0.095 is 0.095. Okay, so this and this are the same thing. It's just the next step. So they might show you the equation like this or like this. And when we put in the calculator, what do we get? It is money, so make sure that once you get your answer, you click up, highlight it, hit enter, and then this is going to be careful with the cents. How many cents? 31 cents, because that 7 tells us to round up, so it's not 30 cents, it's 31. Very good. 5 or more, round up. Okay, but not every time. When it's money, for sure. Right now, we'll do an example where it's not. We're not going to round up. All right, next problem. I don't know how to say that. Mendelssohn Stradivarius violin was estimated to be worth approximately $1,700,000 in 1990. The violin is expected to increase in value by approximately 7.5% each year. Estimate the value of the violin in 2010. All right. So again, they want the final value, so I don't know that. Let's find it. The initial value is going to be, what's Sunny? 1,700,000. Parentheses 1, is it going to be plus or minus, Kevin? It's going to be plus. plus. Daniel, can you give me the rate in decimals? 0.075. Ooh, careful. That is incorrect. So, if you're not sure, double check yourself. Divide 7.5 by 100. Did you say 0.075 or 0.75? Okay, sorry, you were right. 0.075. All right, raised to the. Can you give me the time there, Zach? What's it going to be? Very good. Raised to the 20. So if you're not sure, if it gets complicated, we can solve. You would do 2010 minus 1990, and that's where you would get the 20 years. Let's plug it in. Careful with all those zeros. 1 plus 0.075 raised to the 20. Alright, if you see the answer is very large, so it changes it to exponential, excuse me, scientific notation, so go ahead and click up, hit enter. That way I can see the value all the way to the cents. So the final value is $7,221,346 with 87 cents. Since the zero is next to the 7, we don't round up. It stays the way it is. Question? Sure. Alright, number 4. Tony purchased a rare 1959 Gibson Les Paul guitar in 2000 for $12,000. Experts estimate that its value will increase by 14% per year. Use the graph to find when the value of the guitar will be $60,000. Do they give me the final value? What is the thing that they're asking? It says find when the value will be that. What are they asking? What is it that I do not know in my equation? The time. Very good. So if I don't know the time, they're asking for when, then I should have everything else in my equation in order for me to answer this. Well, let's say it's a graph. So, do I have the final value? Yes, it is 60,000. The initial value then is, Crystal, what's the initial value? 12,000. 1, are we adding or subtracting, Reggie? It says increases. We're adding. Can you change that rate for me, Isabel, to percent? I mean, to a decimal? Just divide it by 100 in the calculator, control enter, and it'll give it to us in a decimal. Very good. All right, and then we do not know t, so you can leave it as t. That's our unknown. Now it says to do a graph, to use the graph. For this problem, I don't like that to use the graph, but I do want to go over how to use the graph. That way you can do it in your assignment, because there will be a problem like that. So let's go ahead and open a graph. Now, 60,000, we're not going to plug that in. We're only going to plug in what's on the right side. 12,000, open parentheses, 1 plus 0.14 raised to the, will the calculator recognize t? No. So what do we have to put? X. So go ahead and put x. Hit enter. I cannot see the graph. Why not? Very good. Let's zoom out. Menu, window, zoom. And I'm going to zoom fit for this one. Because it's so big, if I zoom out, and it's going to look kind of funny when I zoom out. So let's just do zoom fit A. Menu, window, zoom, and A. Okay. It should look something like this now. Now if you notice, mine is about 48,000, the height. These numbers are really, really big. So the graph doesn't help me that much, even if I add a grid. It's better to go to the table. go Control T. Also, careful with that. In 0 years, it's not really 0 years, it's the year 2000. So 1 is 2001, 2002, 2003, 2004. Let's find out when it's going to hit 60,000. Okay, almost 13 years is correct, Greg. So 12 years is 57 something, and then 13 is 65. So it's right in between 12 and 13. And if we had answer choices, maybe we would be able to answer it just with this. In case it's more specific, let's go back to the calculator page, because you are going to do one that is very, very specific in your homework. Do you guys know, if I'm going to be in the calculator page, where can I go that I can plug in this whole equation and solve for t? Algebra, menu, algebra, numerical solve. Go ahead and do menu, algebra, numerical solve. And let's type it in. 60,000, watch out with all those zeros, equals 12,000, parentheses, 1 plus 0.14, close parentheses, carry. And then this one you can use the t, okay, because it's not a graph, so I can use the t if I want. But be careful, click to the right so your icon gets big, so we're not in the exponent box anymore. And then put comma, the variable you're solving for. If you use x, then you would put x. Since I put t, I'm going to put comma t, so the calculator knows what I'm solving for. Hit enter. 12.2831. If I want to be more specific, I could even do 0.2831 times 12, and that'll give me the months. So it'd be 12 years and 3 months, 3.4 months, you know, if it was more specific. So let's go ahead and put t equals 12.2831, and then it would be approximately in 2012 and 3 months. Okay, so we would just read our answer choices and pick the best one. Turn it over. Backside is the same thing, so I'm not going to go over all of it. Okay. If you are having a hard time, it is good to reread it because it's the same thing. So just extra notes there. The one I really do want to focus on is number 2. The population of a town is 4,200 and increases at a rate of 3% per year. 7 years. So for 7 years, we want to know how much it increases. So 4,200 is my initial value. Parentheses, we are increasing, so it's 1 plus 3%, so 0.03 raised to the power of 7. Then you would put in the calculator. 4,200, 1 plus 0.03 raised to the 7. Enter. My answer is 5165.47. 5,165.47. What are we talking about? People. Can I have 0.47 of a person? Am I going to round up? No. I cannot have 0.47 of a person. Even if I have 0.89 or 0.9 of a person, I cannot round up because that's not an actual person. So then you would leave it at 5165. 5,165 people are going to be alive in 7 years in this town. Okay. So if you're talking about people or objects, you can't have 0.46 or point anything of a person or an object. So just leave it at what it is. Okay. Also, there is a problem in your homework right now, so let's go ahead and look at it, where it's mixing months and years. So go ahead and let's look at number 2 in your homework. This will be the last thing before I let you guys get started. Number of subscribers. So we're talking about people. Can't have half a person. To an online book club is growing exponentially. If there are 100,000 initial subscribers and it grows 2.4% per month, how many subscribers will there be after 1 year? If my rate is given in months, then when I do my equation, my time has to also be in months. Do they give me the time in months? No. So we have to change it to months. So T is going to be 12. Okay. They always have to match. If the rate is in months, the time has to be in months. The rate is the deciding factor. If the rate is in years and they give you the time in months, then you would change it to years. This is the one that decides. All right, so watch out for that. Also, we shouldn't have decimals because we're subscribers, people. All right, go ahead and get started. If you have any questions, let me know.